Grab out your graphing calculator. Ready for today? Grab out your graphing calculator. What? Oh, the green stuff is very helpful. It's my saying, hey, this type of problem. Like last chapter, there was one where it was like given ratios make triangles. That was a huge idea as far as being able to solve those types of problems. This one, if you're trying to find a unit vector, that's also another tricky type of problem. So I wrote the way to do it off to the side. So if you did not highlight yesterday how to find a unit vector, you might want to highlight that or put a star or whatever you do to say like, hey, this is kind of important, it's kind of tricky, you probably want to study it. To find a unit vector, you need to have a length of 1. Length of 1, wait, what do we say length is for vectors? What's a snazzy term for it? Magnitude. We want the magnitude to be 1. The magnitude is probably not 1 to begin with. How do we find magnitude? What did I use to get root 26? Pythagorean theorem. Good, because I had the horizontal and vertical. All I needed was Pythagorean to get the hypotenuse, which was the magnitude. And then I take the original components of u, and I say, cool, let's scale them back by that magnitude that's current, and by scaling back by, find a similar triangle with all of the sides divided by that root 26, I will get the magnitude to be 1, and the horizontal vertical will be as well as they appear. What did I not take time to do? Rationalize. Do you guys know how to rationalize? Multiply top and bottom. Square root of 26. Just randomly, because someone, I think it was Aryan, was doing a elite SAT prep the other day, and it gave him the following and asked him to simplify. What if you were supposed to simplify something? Oh, sorry, hold on. My smart board is being done today. That tray is not working, but the touch sensitive is, so I just have to go here and say, please be a pen. Pen. This will be fun. So, what if I was to give you something like 1 over 1 plus root 3? How do you simplify that? 1 conjugate. Good. Multiply top and bottom by 1 minus root 3. Make sure that you FOIL. What if I was to give you something like 2 over 3 plus 5i? Ooh, it's a complex number. Multiply by 3 minus 5i, 3 minus 5i. On the bottom, you get a difference of squares. The i's cancel out. You get an I squared. Good. Here's a struggle. How am I going to do this? Let's see. Can you become an eraser? Oh, you can. Alright, next page. We need to work up to word problems, but to do that, we need to talk about. So, question. How hard is it to add, subtract, multiply by a scalar vectors that have their components? Either the a, b, and the sideways carrots, or the ai plus b, j. How hard was it to add, subtract, multiply those ones? Easy, cheesy. Just take the horizontals and put them together. Take the verticals, put them together. The dilemma is, what if they give it to us in magnitude and direction form, and we need the component form? Or, what do we do if they give us the components and we need the direction magnitude? I've actually already written this down, we just didn't make a special note of it. I think a special note is helpful as far as having like different types of problems. So, this page says, okay, they give us the nice A and B. They give us the nice horizontal and vertical components. Be green. Okay. They give us the nice horizontal and vertical components. The I and the J, remember, handwritten notation. You guys put your little arrows above?
Yes.
Good. Over here too? Remember the I and the J, A times I, that's what makes it go to the right. B times J makes it go up. But either way, the A and the B are the two legs. A is the horizontal, B is the vertical. We've already talked about how to find the magnitude. You just use Pythagorean theorem. That's easy. So the magnitude of the vector would be a squared plus b squared, square rooted. Positive because the magnitude of the vector will always be positive. The negative will be denoted by the sign. The direction will be denoted by the sign. However, how would we find theta? Do you guys remember? I said it really briefly yesterday. How would we find theta? We're given A and B. Magnitude is Pythagorean. Theta Tangent would be the easiest. Tangent lets us use the original givens without having to use the hypotenuse or the magnitude. So we could just use tangent. Tangent inverse, more particularly. Struggle. Please be an eraser. That was a little overkill. Now, please be a pen. Struggle. Okay. However, really quickly, when you're solving for theta given A and B, wait, that is solving for theta. Struggle. Please don't be a pen anymore. Do you guys see why I have to move this? What are we supposed to be solving for? That's not A or B. Who is this? Okay. That was down there, solving for theta. So what if we're given theta and magnitude, and we're trying to find A and B? Tan theta over A. Nope. Because if we did do tan theta equals B over A, how do we know who's B and how do we know who's A? We just know what the division is. We don't know what the actual pieces were. Does that make sense? So we need to find both A and B. So if we're given theta and given the magnitude, we have to be given both. Either a vector is given with direction and magnitude, or the vector is given with horizontal and vertical components. So let's say we're given theta, we would be given the magnitude as well. How could we find for A? Yeah, because if I know this guy and this guy, hypotenuse, angle, adjacent would find me A, right? Or I should say cosine, which would find me A. So I could say A is equal to, can we just say this is an equals? Okay, is equal to the magnitude times cosine of theta. Check it. Cosine of theta would equal A over magnitude, multiply the magnitude on the other side. It's really just cosine with the hypotenuse multiplied over. One more time. It's really just cosine of theta with the magnitude with the hypotenuse. Instead of adjacent over hypotenuse, hypotenuse got moved to the other side. So can you guys use a similar idea to tell me what B would be? Good. Opposite over hypotenuse. Sine of theta equals B over magnitude. I'm not going to write the over magnitude because I'm going to multiply on the other side. So I'm going to say B is equal to magnitude or hypotenuse times sine of theta. Got it. So to find A and B, I use the hypotenuse or the magnitude times, well, cosine of theta for A, sine of theta for B. A way of memorizing, well, A is the adjacent, so of course cosine. B is the opposite, so of course sine. Now, for this bottom one, where we are finding theta, I probably should have you do a quick note. And that quick note, let me make it a different color. Note. Watch. Maybe I don't want to do watch. Check. Let's change that to check. Okay. Check for the correct quadrant. Check the pick. What do I mean? Remember, tangent inverse is limited as to what it can give you for answers. That whole one-to-one and vertical horizontal line test, tangent inverse, sine inverse, cosine inverse are restricted in what the calculator would give you. So tangent inverse in a calculator, because these are real-world problems, probably not very nice unit circle-y angles. When you plug in tangent inverse to your calculator, does anybody remember where it looks? Quadrant 1, 0 to 90, and quadrant 4, negative 90 to 0. So it looks from negative pi over 2 to pi over 2. What if your angle is over here? You're going to have to take what the calculator gives you, which should be in this quadrant, and add 180. So it might not be natural, it might not be perfectly lining up, but whatever you get from tangent inverse can be used for. So I'm going to change this notation a little bit, and let's see if it makes a little sense after what I just said. I'm going to take away the equals, because to be honest, tangent inverse will not always, what the calculator gives you for tangent inverse will not always match up with the angle that you're trying to find. So I am going to put colon, theta colon, not equals, I'm going to put use tangent inverse. Use tangent inverse of b over a. It might be the exact answer, or it might be something that you need to use by adding to 180, subtracting from 180, etc. You might need to just use what the tangent inverse finds you, or solves for you. So, quick note, quick warning, good thing to highlight or star, that we're going to be using tangent inverse, but it might not always be the answer, but somehow we can use it to find the data that we need. Okay, so we have an example. My thetas are misplaced. I don't know why, so let's move them over. Oh, now it's a 10. Oh. Let me move this to make it a little bit better. Okay. I don't know, the thetas get all... Sometimes when there are updates and whatnot, like my formatting gets kind of weird. Okay, there we go. We're given two different vectors, vector u and vector v. They want us to find the component form of the sum Wait a minute, what's the point of this whole thing? Find the component form of the sum of u and v with direction angles theta u and theta v, and find the direction and magnitude of the resultant. It sure sounds like they want me to put these together, right guys? Okay, so two different vectors. I drew them for you. 50 is going to be a little bit longer than 30. I made this kind of like 5 units and this kind of like 3 units because it's a 5 to 3 ratio. This one is 30 degrees-ish. This one is 110 degrees-ish. So I approximated. They want us to put them together. Let me show you something, okay? As you guys are getting this down, let me show you something. We've looked at the graphical representation of what's going on. If we weren't to go to component form, we would need to do the following. I know that they tell us to, and we will in a second. If we weren't to go to component form, here's what we need to do. We would need to say, okay, this guy is 30 degrees. Label him like a geometry problem. This guy is 50. This guy is 110 degrees. And this guy is 30. Now, question. How could we get a graphical representation of the sum? Because remember, right up here, the whole goal of this problem is to find vector u plus vector v, and ultimately to figure out its direction and magnitude. So it's like, well, they give us directions and magnitudes. Why don't we just use that? Why do we need to go to component form? Because what they want is direction and magnitude of the resultant of, remember, resultant is a snazzy name for the net result or for the sum of the two together. Graphically, can I connect these two head to head right now? Is that what vector diagrams are? Hold on. You guys know this. Hold on. We were doing pictures yesterday, beginning of class, right? These ones. Okay. When we were solving, was I able to keep these vectors in the exact same position and just connect them? Keep them in the exact same position and just connect them head to head? Never. How did I connect them? Tail to head. I connect the two vectors head to tail, but my resultant goes from the tail from the very, very, very initial point to the very, very final. The resultant goes from the very initial to the very final, or we could say from the tail of one to the head of the other. I need that flow. I need the flow to be working together in a sense, or I need to see it put together, not working opposite each other, but all together, all in tandem in a sense. Even though horizontally they're working together, well, I guess this one, horizontally and vertically, they're kind of working together. This one, vertically, they're working against each other. This one's pointed down, that one's pointed up. This one's pointed left, that one's pointed right. But in order to see that, the overall result, what happens if I have like this force and that force acting together? Oh, hey, this is going to occur. I need to make sure that I have these two vectors when I add them. I need the head of one to the tail of the other. I can see that flow. And the resultant says go from the very beginning to the very end and from the tail of one to the head of the other. Okay? That's how I always connect resultants. Let's go to this one over here. And I asked you guys, how can we look at the sum? Is it okay the way it is just to connect? Yeah. So what do I have to do? I I need to shift. Remember we said equal vectors we can put anywhere as long as it has the same magnitude, right? And the same direction. So how do I show that? Well, since I have a computer, I can go ahead and clone it. I can copy and paste it. For you guys, you're going to try to draw a line that is parallel and the exact same length, I would say, up here at there he is. Up here at the top. Right? I need to shift this U up, and then I can go ahead and say, okay, now I can connect. I can connect with the resultant just so I can make it all nice and snazzy and neat. I'll go ahead and do this, and I'll make them red. And I'll say the resultant goes from the tail of one, the very beginning of one, to the head of the last, or the other. Do you guys see the resultant? Yes or no? Okay. That guy is the sun. This guy right here is the sun. This is U plus V. You can call him W if you want. But the question is, I can see him, but can you figure out what his magnitude and direction are? Magnitude, what do I need? The length. Direction, what do I need? The angle. Any ideas how I can find it? Okay. How?
Do 110 minus 30.
Okay. If I did 110 minus 30, that's this entire angle. Take away 30, I'll get this piece. Does that help me with that piece? It could. So I can say this piece right here is equal to 110 minus 30 is 80. How does that help me with that piece?
So then you do 110 minus 80, and that's 30.
But 110 minus 80 gets me this whole piece. The whole time, 110 minus 30, that gets me this angle. Sorry, I apologize. Gets me this angle. So I know that the one that I want shares part of that. It's part 30 and part that. Complete what triangle? Ooh! I have stuff for a triangle, for an obtuse triangle, for a non-right triangle. I have 30 as a side, and I have 50 as a side, and I have 80 as an angle. What can I do with a angle side?
Dang it, Ryan. SAS? You could just do that.
Wait. Would it be nicer if I had SAS? Is there any way that I can find that angle?
Is it a 90-degree angle?
I don't know for sure. I do know these two lines are parallel, and this is a transversal cutting it. Ooh, geometry! If I had 80 being this angle down here, and these two lines are parallel, question, same side interior, what's going on here?
80?
No, it's not 80, that's alternate interior, 110, it's supplementary. I know this guy is 110.
Already?
Although, Colby, real quick, 110 and 80 makes 190, so it's not 110. What is it instead?
80 is going fully out.
80 is here. Interior of the parallel lines. So this wouldn't be 110. What would it be? 100. 180 minus 80. I need the supplementary angle.
Wait, but isn't that 80 not the angle? Because we're going off from the red line as the end of the triangle? Oh, okay, never mind. I got you.
Yeah.
But then, okay, I got it.
So if 80 is not even in the triangle, right? So I wouldn't have been able to use 80 anyway. Some of you guys were thinking maybe the 80, but remember the 80 goes outside the triangle, but I need the 80 because I know that same side interior angles with parallel lines, this guy needs to be 100. 100 plus 80 is 180. So now I can use law of cosines and I can say, okay, who do I need? This guy. So I can say c squared is equal to 30 squared plus 50 squared minus 2 times what law am I using right now?
Cosine.
Law of cosines. Cosine of 100 degrees. I can find the magnitude by law of cosines. So, you guys, I told you to get your calculators out because they're going to be very, 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 very helpful today. If I plug in for law of cosines, shouldn't I square root both sides? So square root of 30 squared plus 50 squared, I can type this all in one line, right? 2 times 30 times 50 times cosine of 100 degrees. Ooh, I should be in degree mode, double check. And I end up with, I believe, C equals 60.
Smiley faces?
I couldn't. Not sure how helpful that would be.
Yeah, they're evil.
C equals, I just can't go too fast. What do you guys got? 62.617? Okay. What is that the same thing as? The length of my resultant, which is my magnitude of my sum. Okay, I have magnitude, but question, what else did I need?
Direction.
Direction. Direction is,
Angle.
see how the angles are being measured, standard position? This guy's 30, that guy's 110. I want this guy right here for my resultant. What angle would you turn? Think of it like a boat. If a boat headed out on this heading, or this bearing, and then turned and headed here and stalled, somebody from the original port, are they going to follow his exact, not flight plan, but his exact plan?
Yes.
No. They're going to get to him as soon as possible. Maybe some guys are in the ocean and got knocked out and there's a shark. Anyway, whatever, they're going to go straight there. How can they go straight there? Well, they're not going to take his bearings. They're going to take the bearings to the final location. Okay? So question, how do I find this guy? 110 minus, no, because that's this angle. I don't want that angle. I want this angle.
Minus 80.
No, because if I do minus 80, I get 30. I want this angle.
180?
And then subtract that.
You find that angle
And then you get that.
You find that angle right
You
there.
find this angle inside the triangle and say 110 take away him will get what's left. 110 take away him will get what's left. I need this angle of the triangle. What's that mean?
Lost.
I can do law of sines if you want. Law of sines? Because can't I say, alright, Lord, patience. I need it. No, no, oh, okay, blue circle of death. Great, go team. Alright, cool kids, look at the picture. How can you set up law of sines? Don't I have sine of 100 over C?
Yeah.
Because I know C, right? Sine of 100 over C equals sine of, I don't know, over who's his opposite angle? 50, go, you don't need me, come on, law of sines. Sine of 100 over C, plug in the full decimal as much as you can, equals sine of I don't know all over 50. Once you find I don't know, subtract it from 110. Let me try to get my computer working again. Okay, now he likes me. Don't use the rounded, remember, use the nice expanded form, yeah?
Oh,
Wait. Dude, I'm so lost.
Daisy does.
You're irritating. Huh?
So I'm going to do sine inverse of 50 times sine of 100 divided by 62. Oh, hold on, let me just go get my nice big one. There we go. Did you guys get 51.81? No, sorry, 51.847? But I don't want 51.847, even though I'm going to write it down. Hold on. Back me up. Who says yes?
Yes.
Cool. For my angle, don't I need, I'll name him alpha since I named him theta, don't I need 110 minus that? So therefore I can say alpha is equal to 110 minus that angle is exactly 58.153. Now, I solved for the direction and the magnitude completely with geometry and laws. Law, sines, law, cosines. I solved completely with geometry and law, sines, law, cosines. I needed parallel lines and properties of parallel lines, the relationships of angles. I needed to think about law of cosines with this little triangle I was able to form to solve for the missing sides and angles. Was it possible? Yes. But what if I had a u plus a v plus a w? Just picture. What if I had a u plus a v plus a w? So what if I had a u here, a v here, and a little w here? So I would need to go u, or I guess we technically went v, and then u, and then w, and then had to connect. Would my picture get complicated?
Not that much.
Yes. It's a yes.
Just believe me, it would be yes. It would get very complicated because it wouldn't just have two parallel lines. It wouldn't just have one transversal. It'd actually have boom, 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 a few parallel lines, and you'd have to use all of those parallel lines with multiple triangles to solve for the overall resultant magnitude. So I want you guys to compare this process of solving with geometry to the process of just using the horizontal and vertical components. We just talked about how you can take magnitude and direction, geometry and triangles. Here's the two different ways. Geometry and triangles, which a physics teacher would definitely show how to do. Geometry and triangles is what you guys just saw. It's time for horizontal and vertical components. Look at your formulas. If I have magnitude and direction, question, how can I change it? How can I change it into components? How can I put vector u?
Oh, you need to equal 1.
How can I plug them into components? It's okay, it's okay. Okay, look at the formulas we just wrote. I want A and B. I've been given theta and magnitude. I want A and B, and I've been given direction and magnitude. I want A and B. I've been given magnitude and direction. Can't I just plug in? Okay, so I am going to plug in. And when I plug in, I'm going to get the following. Ready? 50 cosine 30, 50 sine 30. Question, do you see the notation I'm using with the side brackets? That's horizontal, vertical, right? Could I have done it with i's and j's? Totally. I'm just using the side brackets because I have them. How can I get vector v in its components? You guys, your turn, go. 30 cosine 110 and 30 sine 110. What am I using? The formulas from the page that we just wrote about how to find A and how to find B. Now what's the cool thing? How do we add once we have components? Just add them. Just add them. So U plus V equals 50 cosine 30 plus 30 cosine 110 and 50 sine 30 plus 30 sine 110. Now, if we wanted to make this approximate, we could go ahead and get those decimals. Also get those decimals so that we can see them. And let's see if it makes sense with what we have up on the board. So 50 cosine of 30. I think Thomas has it. Just double checking him. Yeah, 33.046. This isn't my final answer. And then I have my, you can just take it over again and say, wait, I want sine instead. So 50 sine of 30 plus 30 sine of 110. I end up with 53.1907 make sense with my picture that I go over 30-ish and up 53-ish? Over 30-ish and up 50-ish? Yeah. Looks pretty stinking good with the picture that we drew. But wait a minute, that wasn't the end. Now, we did use component form and we did find the sum, and that is true, but they want us to use that sum to figure out the magnitude, right? And the direction. Okay. How do we find magnitude if we're given A and B of the resultant? I hear you guys talking, but I'm not really sure it's anything helpful to what we're doing. So, how do I find magnitude given A and B?
A squared plus B squared is the square of all of that.
Yeah, just remember the 33.040 that's the horizontal. And the 53.1907 is the vertical. And there's my resultant that I'm trying to find. So all I have to do is say, well, to find the magnitude, which is the length, I just need to do A squared plus B squared. Sweet, let's go do that. This guy squared plus that guy squared. And I'm going to square root the whole thing, right? Magnitude, 62.617. Hey! I didn't really have to use geometry besides Pythagorean theorem and these cool little formulas. Magnitude, 62.617. No law of cosines necessary because I broke it down into little baby right triangles and then added all the horizontal verticals together. Got my new right triangle and just used Pythag. How am I going to find the theta? We labeled this one a little weird because I used theta a little early. Alpha is the theta of the resultant. Can't I just use tangent inverse like we talked about in the page before? Of the 53-ish one? All over the 33-ish one? So what happens when I do that? Tangent inverse of B over A ends up equaling equaling 58.153. How's that look? How's it look, guys? Very good. What made all the difference? Breaking vectors into their what first? Breaking vectors into their what first? Components. So if I use the formula to say magnitude cosine angle, magnitude sine angle, hey, those are the components. I can just do simple math of adding them. I can get my two sides, which are the legs of my resultant, and I don't have to do any shifting or parallel lines and transversals and same side alternate interiors or supplementary and then law of cosines. I don't have to do all that. Law of decimals might result. Just be careful that you don't end until the, don't round until the end. Okay, so what are we going to do if we have a problem like this? No, we're going to try it. Because, first of all, this is the very end of homework. This is like in the 80s, almost 90s. There's a lot of homework to do before then. And then number two, we're going to say, all right, what's going on? The cranes shown in the figure are lifting an object that weighs 20,240 pounds. Find the tension in the cable of each crane. Please show using vectors. All right, do you guys see some angles up here?
Yeah.
Where's the 20,240 pounds thing? The box in the middle. So the weight of the box combined with gravity, or maybe weight does take into account gravity, you guys should know this. The mass of the box with gravity is going to end up that the box, 20,240 pounds of it, are trying to fall to the ground. But what are the cranes doing? Not only holding it, but also lifting it. In order to lift something, how much or how many pounds of force do you think has to be accomplished by the two cranes in tandem? You would think more, but it actually just needs to equal it. If you can put as much, or if you can assert the the same number of pounds, then you offset what's holding it to the ground and you'll be able to lift it just fine. You can kind of think like someone in a pool. Anyway, there's lots of physics in it, but let's just come back. In order for the cranes to be able to lift, they have to offset, they have to be able to cancel out these or this weight of the box. So here's the idea. We don't know how much tension is in the cable. That's the whole point. We're not sure what that is. So I'm going to call this guy X, and I'm going to call this guy Y. Okay? The tensions in the cables are the unknowns, and they're the exact same thing as X is the magnitude of, we'll call it U, which is, we'll call him the blue crane. And Y is going to be the magnitude of V, which we'll call the red crane. Okay? I can figure out U in components by using my little formulas. And I can say, okay, U is the blue crane, so I'm going to make that Y times cosine of 44.5 and Y times sine of 44.5. I don't know the magnitude, but I can write it. Using similar logic, what do you guys think I'm going to do for V, which is the red crane? Same thing, but X times cosine of, now here's the struggle, should I use 24.3? Isn't it being measured a different way than the 44.5? So I'm not going to use the 24.3. It's going to get a little confusing with whether something's moving to the right or to the left. I'm going to use instead 180 minus 24.3, which will end up being 155.7. You guys can go and start packing up. So I need to show you something. Let's start as we start packing up. First of all, you should be able to, and that is what's due tomorrow, attend all of the homework up until the word problems fully. And then second of all, once you get the word problems, some are easier, some are harder. Here's what's interesting. When we add down, question, does this need to move horizontally at all? No. So this one's going to equal 0. The horizontal 0. But vertically, what does it need to equal? 20,240. Is there a way to solve for that? 2 systems, 2 unknowns, get out of here. See you tomorrow. All of the homework attempted up to word problems and word problems started. Michael can. Thank you for the extra minute. I appreciate it.
The last 45 minutes.
Where are you going?
Honors Chem.
Okay.
You know what?
I just told you.
Go get your books in the back. Is there in the hallway, yeah?
That's fine.
I'm just.
So,
Your costume's not checked.
Yeah.
Bring those
Yeah, I'm just confused. I'm like, what?
feel issues.
That's what it is.
Thank you. Can I get a little bit more time to use
All my stories. Yeah, that's it. Really?
I'm gonna do. Chief.
Brendan, I have an idea.
I like.
I got that first step right. I was trying to do it. Right.
But as many,
This is 3 times cotangent, so 3 cosine over sine. And I'm going to change him, and I'm going to change him too.
as many as everywhere. Why?
I think I like that you were trying to do it, just a little off.
Yeah.
Why can't I do it?
This guy needs sine over sine.
Right.
This guy needs cosine over cosine. So yeah, that's a big one.
Misty, did someone find the black calculator back there?
That white one.
Because I had it this morning during zero period, but I
Are
couldn't
you
find it.
sore?
Can I go check my locker?
So cool. Yeah, check your locker and then. Yeah, this every step I take is painful, especially going down the stairs.
Oh.
Here, I'll show you something. John, this isn't it.
Yeah?
Right here.
Sorry. I'll go look in my locker.
Okay.
Who are you talking about?